Hello all, this is Sunil. Welcome to my channel. So in advanced control system, this is the second video. So in this video, basically how we can derive state space realization from system dynamics, and also once the block diagram is given, how we can represent state space realization. Okay, these are the topics that I'll discuss today. So in the beginning, I'll discuss once the system dynamics is are given, how we can realize the state space realization. Okay, state space realization from system dynamics. Okay, in this I've taken the first example, mass spring damper system. Okay, so in your exam, either they give such example, mass spring damper system, or they can directly give you the final differential equation. Okay, if this is not given, then you can derive very easily. It's very simple. Mass equal Newton's law, force equal to mass into acceleration. Okay, so with damper term, I have taken x dot. With this is the spring term. With that, I have taken x. Okay, x is our displacement x. Okay, mass into acceleration. Okay, whatever displacement is that we have taken second derivative. Okay, this is how for this schematic, this is how we represent differential equation. Okay, so from here, how we are able to get state space, how we are going to realize state space system. Okay, this is important now. So once we have reached up to this state, the next task is to see the highest derivative in this equation. So the highest derivative is x2 dot. That highest derivative, keep it on left hand side. Okay, remaining all the terms on right hand side. Okay, remaining all the terms on the right hand side. This is our first task. Once from this step to this step in, once we have arrived, now the task is to define the states. Okay, so once we define the states, the next step is to get to take first order ODE. Okay, so before we take first order ODE, we have to define the states. We have to define the states in such a way that when we take an x1 dot, it should be x2. When we take an x2 dot, this final equation has to frame it. Once you practice 2 to 3 problems, you will get some idea how to do this. Okay, so I have taken here x as x1, x dot as x2. Okay, such that when I take x1 dot, it will be x dot. X dot is nothing but x2. Okay, so we have honored this. When we take x2 dot, x double dot is this final expression. Okay, so this is how you have to frame it. So I have taken here x1, x as x1, x dot as x2. Okay, these are two states, and then we have to frame the first order ODE of states. So it's very simple. X1 dot, x dot is nothing but x2. This is the now x2 dot, x dot is x double dot. Okay, x dot again we are taking derivative, so x double dot. So I have written the same equation here. Okay, in this equation, wherever I have x, that x I have to replace with x1. So in the expression I have written here x1. Wherever I have x dot, okay, that I have to replace with x2. So I have replaced here with x2. It is same as this f by m. Okay, our output is x, but x is replaced with x1. So that is why I written here y equal to x1. Okay, once we have framed this, okay, here I represented here in matrix representation. Okay, matrix. So x1 dot x2 dot. So we have only x2 term, that is why here 1. With x1 I have minus k by m. With x2 I have minus b by m. Okay, and input is, okay, we have applied the force, right? So with force I have coefficient 1 by m. So I have taken here 1 by m. In output I have only x1 term. So I have taken here 1. Okay, here I have just copy pasted the same differential equations, first order ODE. From here, how do we represent block diagram? Okay, just listen. Since we have two first order ODE, there will be two integrator. Okay, you have to write two integrator. Next step is the output of integrator will be states. Okay, output of integrators will be state. And input of integrator, okay, I'll take different pen. Okay, let me take the input of integrator will be derivative. Since we have taken a x1, it will be x1 dot. As we have taken x2, the input will be x2 dot. Okay, the first one is what? X1 dot equal to x2. X1 dot equal to x2, that already got satisfied here. X1 dot equal to x2. Okay, now come to second equation. In second equation, what The moment you see an equation, focus on the summer block. Okay, summer block. Whatever I have now left hand side, it will be the output. So x dot will be output. Whatever I have right hand side, take it as input. Okay, so for this summer it will be input. Okay, now you see here with x1. So this is the x1, right? I have k by m. So I have taken here k by m minus and have included here. With h2, okay, I have b by m. That's why I have taken b by m. With f, I have 1 by m. That's why I have taken here block 1 by m. And I finally fed as input to this summer. Okay, very simple. Once you practice 2 to 3 problem, it will become very easy. Let's go to second problem now. Okay. So here I have taken a simple RLC circuit. Okay, it is simple RLC circuit. For this RLC circuit, I written here KVL. Okay, I'm sure that you already know this. So simply I taken the drop across this R, drop across L, drop across C equal to supply U of t. Okay, this is the final expression of R times I L di by dt 1 by C integral I dt equal to U of t. As explained before, same concept here. Focus on highest derivative. Keep it on left hand side, remaining all the terms on right hand side. Simple algebraic manipulation. As explained before, we have to get in this way x1 dot equal to x2. So that's why I have taken here integral of I as state x1 and I as x2 and integral of I as x1 such that when I take derivative, integral and derivative will cancel each other and we remain with I, and that I is x2. Okay, this is how I define the states. Once I have defined the state, the next task is to get first order ODE. So as explained before, x1 dot equal to integral and derivative will cancel each other. So I is nothing but x2. So I wrote here x2 dot. So I dot. Okay. I dot means what? Di by dt. So I have to write this complete equation here. In this equation, so wherever I have integral of I, that integral of I replace with x1. So that's why I replace it with x1. Same way, I have an ID here. Okay, that I have to replace with x2. That's why I replace it with x2. I remaining term remains same. Once I frame this thing, it is very easy. Write it in matrix representation as explained before. Okay, 0 and 1, the coefficient minus 1 by LC, the coefficient minus R by L, and input 1 by L. Okay, and output Y as, okay, what is Y? Output across capacitor. Okay, what is output across capacitor? 1 by C integral I dt. But what is your integral I? State x1. Okay, that state x1 I written here. That 1 by C is written here. So, okay, that will appear here. Now comes to block diagram representation. Okay, as explained before, we have two first order ODE. There will be two integrator. Okay, output of integrator will be states. Okay, and how input of integrator will be derivative of that. Okay, derivative of state. Okay, now the first equation is x1 dot equal to x2. That already have satisfied here. X1 dot equal to x2. Now come to second equation x2 dot. The moment you see the equation, focus on summer. Okay, left hand side, keep it as output of summer. That is there. Now whatever we have right hand side, just feed as input. Okay. So with input u of t, I have 1 by L. So I have taken 1 by L block. With state x1, I have 1 by LC. So with state x1, I have taken 1 by LC. That minus n I included here. With state x2, I have R by L. So with state x2, I have R by L. So finally, I have added these two and fed as to this summer. Okay. So this is how we represent block diagram. It's very simple. The moment you practice 2 to 3 problems, it becomes very easy. Okay. Now we have one more example. So in exam, if you see such block diagram, how do we realize state space realization? Okay. It's very simple as explained before. The moment you see an integrator, two integrator are there. So in your mind, you should come it is second order dynamics. Okay. An output of integrator will be state I have taken as x1. Here I have taken as x2. Input of integrator will be derivative of that state. So x1 dot, x2, so x2 dot. Okay. The moment you see summer, output, write it and left hand side x1 dot. Okay. These are the three inputs. So this you write it in right hand side. Okay. Output will be left hand side. Input will be right hand side. Okay. So three inputs are there. So there are three terms. Okay. From state x1 I have a11. So a11. And then from state x2 I have a12. Okay, from input you have B1, so B1 and U. Same way, output of this summer block, write it in left hand side. Okay, let me take different way, so you'll not confuse here. Okay, so the input here, and this is the input. So here input I have B2 with U. So B2 with U. Okay. And here again two terms are some clubbing up. So A22 with X2. Okay, A22 with X2. So I have taken here A22 and I have an A21. Okay, A21 with X1. So that is clubbed here to the summer. So here A21 and X1. It's very simple. Just focus on an integrated term, define the states, focus on the summer block. Now you write these equations. Okay. Once you write these equations, very easy represented in matrix representation. Okay. Now one more equation is y. What is y? C1 and x1, C2 and x2. So same thing I written C1 and x1, C2 and x2. Because of summer I have taken a plus sign. Now I represented in matrix representation. So x1 dot and x2 dot. With x1 and x2 we have a11, a12. Okay. With x1 and x2 I have a21 and a22. And with input u I have b1, b2, and y I have with state x1, x2 I have c1 and c2. Okay, it's very simple. The more you practice 2 to 3 problems, it becomes very easy. Thank you for joining.